Here's something most doctors won't tell you until it's too late. The very first sign that your body is aging faster than it should isn't gray hair, it's not wrinkles, and it's not even memory loss. It's your legs. The moment your legs start feeling weak, heavy, or unsteady, your body is sending you a 5-alarm warning signal. And if you ignore it, the consequences go far beyond just struggling to climb a staircase. Let's talk about something that affects hundreds of millions of people worldwide, yet almost nobody connects the dots until serious damage has already been done. Leg weakness. And today, you're going to learn exactly why it happens, what it means for the rest of your health, and the 6 most powerful foods on earth that can reverse it faster than you'd ever believe possible. Now, before we get into the foods, you need to understand something fundamental. Your legs are not just limbs. They are the engine of your entire body. Think about it. Your legs contain over 60% of your total muscle mass. That's more than half of everything your body has in terms of muscle. And muscle, as science now overwhelmingly confirms, is not just about strength or looks. Muscle is a metabolic organ. It regulates your blood sugar, it supports your immune system, it protects your joints, it keeps your hormones balanced, and it literally determines how long you live. There's a concept in medicine called skeletal muscle as an endocrine organ, and it means your muscles actually secrete signaling molecules called myokines every time they contract. These myokines communicate with your brain, your liver, your fat tissue, your heart, your entire body. When your leg muscles are strong and active, they flood your system with anti-inflammatory, life-extending, brain-protecting signals. But when those muscles weaken, those signals disappear, and the body begins to break down quietly, invisibly, from the inside out. Here's what the research tells us. A landmark study published in the Journal of Gerontology found that grip strength and leg strength were among the single most powerful predictors of mortality in older adults. Stronger than cholesterol levels, stronger than blood pressure, and in some cases even stronger than smoking status. Let that sink in for a moment. Your leg strength may literally predict how long you're going to live. And the scary part, muscle loss, the medical term for which is sarcopenia, begins earlier than most people realize. Scientists now confirm it can start as early as your 30s. Yes, your 30s, and accelerates dramatically after age 50. By the time most people notice it, they've already lost a significant percentage of their muscle mass. The weakness crept in silently, disguised as tiredness, disguised as just getting older, disguised as needing to hold the railing going downstairs. But here's what makes this conversation so important and so hopeful at the same time. Muscle loss is not inevitable. It is not irreversible. And the most powerful tool you have to fight it is not a gym membership. It's not an expensive supplement. It's something you do 3 times a day without even thinking about it. It's what you eat. The food on your plate has a direct, measurable, scientifically documented effect on the health of your leg muscles. Certain foods trigger muscle protein synthesis. That's the biological process by which your body builds and repairs muscle tissue. Other foods reduce the chronic inflammation that silently eats away at muscle fibers year after year. And some foods do something even more remarkable. They directly activate the genetic pathways that tell your body to preserve and grow muscle even as you age. So let's talk about those foods. And let's start with the one that most people are either eating completely wrong or avoiding for reasons that are now scientifically outdated. Food number 1, eggs, not egg whites, not a reduced fat egg product from a carton, whole eggs with the yolk. And here's why this matters so much that researchers at the University of Illinois designed an entire study around it. In that study, participants who ate whole eggs after resistance exercise had 40% greater muscle protein synthesis compared to those who ate only egg whites. Even when the total protein content was identical, 40% greater from the same amount of protein, the difference was the yolk. The egg yolk contains something called leucine in its most bioavailable form, along with a cascade of fat-soluble nutrients, vitamin D, vitamin K2, phospholipids, and choline that work synergistically to activate a pathway in your muscle cells called mTOR. mTOR is essentially the master switch for muscle growth. When it's turned on, your body shifts into repair and build mode. When it's chronically suppressed, which happens with poor nutrition, chronic stress, and aging, your muscles slowly waste away. But eggs do something else that's particularly relevant for leg strength. They are one of the richest dietary sources of choline, a nutrient that is critically important for neuromuscular function, meaning the ability of your nerves to communicate with your muscles. You see, a muscle doesn't contract on its own. It contracts because a nerve fires a signal at something called the neuromuscular junction using a neurotransmitter called acetylcholine. Choline is the raw material your body uses to make acetylcholine. When choline levels are low, that signal gets weaker. Your muscles don't fire properly. They feel sluggish, uncoordinated, slow to respond, and over time, that neurological disconnect contributes directly to the kind of leg weakness that makes people feel unsteady on their feet. Studies show that a significant percentage of adults in developed countries are chronically under-consuming choline, and most of them don't even know it because the symptoms develop so gradually that they're dismissed as normal aging. 2 whole eggs per day gives you a powerful dose of this critical nutrient along with high-quality complete protein, meaning all 9 essential amino acids your body cannot manufacture on its own and must obtain from food. Now, while we're on the subject of protein and amino acids, let's move to the second food because this one surprises almost everyone, and its mechanism for preserving leg muscle is unlike anything else on this list. Food number 2, fatty fish, particularly wild salmon, sardines, and mackerel. Most people know fish is healthy, but most people don't know why it's particularly powerful for muscle preservation. And the answer has nothing to do with its protein content. The real magic is in the omega-3 fatty acids, specifically EPA and DHA. And what these molecules do inside your muscle tissue is nothing short of extraordinary. Your muscle cells have membranes, thin flexible walls that control what gets in and what gets out. The composition of those membranes, how fluid, how responsive, how sensitive they are, directly affects how well the muscle can receive anabolic signals from hormones like insulin and growth hormone. When your cell membranes are rich in omega-3 fatty acids, they become more fluid, more permeable to these signals. Essentially, omega-3s make your muscles more sensitive to the body's own muscle-building hormones. A groundbreaking study published in the American Journal of Clinical Nutrition found that omega-3 supplementation in older adults significantly increased muscle protein synthesis rates even without any changes in exercise. The muscles became more anabolically responsive, more responsive to feeding, more responsive to movement, more responsive to the body's natural hormonal signals. And in another major clinical trial, older adults who consumed omega-3 rich fish regularly showed significantly less age-related muscle loss over a 3-year follow-up period compared to those who didn't. But here's what makes this even more powerful. Omega-3s are among the most potent natural anti-inflammatory compounds known to science. And chronic low-grade inflammation, sometimes called inflammaging, is now recognized as one of the primary drivers of sarcopenia. Inflammatory molecules like interleukin-6 and TNF-alpha directly interfere with muscle protein synthesis and accelerate muscle protein breakdown. They are, in a very real biological sense, eating your muscles alive. Omega-3s from fatty fish suppress these inflammatory pathways at the molecular level, quieting the fire that's consuming your muscle tissue year after year. Aim for 2 to 3 servings of fatty fish per week. If you can tolerate sardines, they are arguably the most powerful option. Bone-in sardines also give you a significant dose of calcium and vitamin D, which, as we'll discuss in a moment, play a crucial role in muscle contraction and leg strength. Now, let's talk about a nutrient that is so deeply connected to leg muscle function that researchers have literally called its deficiency the silent epidemic of muscle weakness. And the food that delivers it most powerfully might already be sitting in your kitchen, or it might be one you've been told to limit for no good reason. Food number 3, grass-fed beef or lamb. Before anyone switches off because of the red meat debate, stay with me because the science here is far more nuanced and far more important than the headlines suggest. The specific reason grass-fed beef belongs on this list has nothing to do with its general protein content. It comes down to 3 specific compounds that are found in meaningful concentrations almost nowhere else in the food supply. The first is creatine. You've probably heard of creatine as a sports supplement, but what most people don't realize is that creatine is a naturally occurring compound that your body synthesizes from amino acids and your muscles store it as phosphocreatine, which is used to rapidly regenerate ATP, your cell's primary energy currency, during high-intensity muscle contractions. When your phosphocreatine stores are adequate, your muscles can generate explosive force, recover quickly between contractions, and sustain activity for longer before fatiguing. When those stores are low, as they chronically are in people who eat little to no red meat, your leg muscles are essentially running on a depleted battery. They fatigue faster, they feel heavy, and they struggle to generate the kind of force needed for something as basic as walking up a slope or rising from a chair without using your arms. A comprehensive meta-analysis published in the Journal of Strength and Conditioning Research confirmed that dietary creatine intake from animal sources directly and significantly improves muscle strength, particularly in older adults, the population most vulnerable to leg weakness. And unlike exogenous creatine supplements, dietary creatine from whole food comes packaged with cofactors that enhance its absorption and utilization inside the muscle cell. The second critical compound in grass-fed beef is carnitine, specifically L-carnitine. Carnitine's job in muscle tissue is to act as a shuttle, transporting long-chain fatty acids across the mitochondrial membrane so they can be burned for energy. Your mitochondria, the power plants of your cells, are where muscle energy is actually produced. And in aging muscle, mitochondrial dysfunction is one of the hallmarks of weakness and fatigue. Carnitine directly supports mitochondrial efficiency, helping your leg muscles extract more energy from fat, reducing oxidative stress inside the cell, and supporting the kind of sustained low-intensity muscle activity, walking, standing, climbing stairs, that defines day-to-day functional strength. The third compound is zinc. Grass-fed beef is one of the most bioavailable sources of zinc in the human diet, far more absorbable than plant-based zinc sources due to the absence of phytates that inhibit absorption. And zinc is not a peripheral nutrient for muscle health. It is absolutely central. Zinc is required for the activity of over 300 enzymes in the human body, including many that are directly involved in muscle protein synthesis, testosterone production, and the regulation of IGF-1, insulin-like growth factor 1, which is one of the most potent anabolic hormones your body produces. Low zinc means low IGF-1 activity, which means slower muscle repair, faster muscle loss, and the kind of persistent leg weakness that people mistakenly attribute to age alone. 2 to 3 servings of grass-fed beef or lamb per week, combined with the eggs and fatty fish we already discussed, creates a dietary foundation for muscle preservation that most people have never experienced, because most people have never put these foods together intentionally with the specific goal in mind. Food number 4, beets. This one is going to surprise you because beets are not typically thought of as a muscle food. They're not high in protein. They're not particularly rich in the amino acids associated with muscle building, but what beets do for your leg muscles operates through a completely different mechanism, one that addresses a problem that becomes increasingly critical as we age, and that almost nobody is talking about in the context of leg strength. That mechanism is nitric oxide production. Beets are extraordinarily rich in dietary nitrates, and when you consume those nitrates, your body converts them through a series of enzymatic reactions involving bacteria on the surface of your tongue and in your gut into nitric oxide. And nitric oxide is, without exaggeration, one of the most important signaling molecules in your body for vascular and muscular function. Here's why this matters so profoundly for leg strength specifically. Your legs are the furthest extremity from your heart. They are also the largest muscle groups in your body with the highest oxygen and nutrient demand during physical activity. Every step you take, every time you stand from a seated position, every time you climb a stair, your leg muscles require an immediate massive increase in blood flow to meet their energy demands. This blood flow is regulated primarily by the diameter of your blood vessels, which is controlled by nitric oxide. When nitric oxide levels are adequate, vessels dilate efficiently, blood rushes in, oxygen is delivered, waste products are cleared, and your muscles perform. When nitric oxide is low, which happens progressively with age, poor diet, and sedentary behavior, vessels don't dilate properly, blood flow to the legs is compromised, muscles receive insufficient oxygen, they fatigue rapidly, they ache, they cramp, and they feel perpetually heavy and weak. A remarkable study published in the Journal of Applied Physiology found that athletes who consumed beetroot juice before exercise showed a significant reduction in oxygen cost during submaximal exercise, meaning their muscles became more efficient, requiring less oxygen to produce the same amount of work. But more relevant to everyday people, a separate study in older adults with peripheral artery disease, a condition characterized by reduced blood flow to the legs, found that dietary nitrate supplementation from beet juice significantly improved their walking distance and reduced leg pain during exertion. But the story of beets gets even better. Beets contain a unique phytonutrient called betalain, the compound responsible for their deep red-purple color. Betalains are potent antioxidants and anti-inflammatory agents that specifically reduce muscle damage and accelerate recovery after physical activity. They work at the cellular level to neutralize reactive oxygen species, the free radicals generated during muscle contraction that in excess damage muscle fiber membranes and contribute to the kind of chronic low-grade muscle injury that quietly degrades leg strength over years and decades. Half a cup of cooked beets 3 to 4 times a week or a small glass of pure beet juice can begin to measurably improve nitric oxide levels and leg muscle perfusion within days, not weeks. Days. The vascular response to dietary nitrates is that rapid. And for people who have been experiencing leg heaviness, cramping, or early fatigue, the subjective improvement can be genuinely remarkable. Food number 5, spinach and dark leafy greens. And here I want to draw your attention to a specific compound in spinach that most nutritionists have never even mentioned in the context of muscle health, because the research on it is relatively new and it is genuinely astonishing. That compound is called ectosterone, or more specifically 20-hydroxyectazone. It belongs to a class of plant steroids called phytoectosteroids, compounds that plants produce for their own regulatory purposes, but that when consumed by humans interact with estrogen receptor, beta, in muscle tissue to stimulate muscle protein synthesis through a pathway that is distinct from and complementary to the mTOR pathway we discussed earlier. A clinical trial published in the prestigious Archives of Toxicology, a study that was funded in part because sports authorities were investigating whether acetostrone should be added to the banned substances list, found that human participants who consumed acetostrone showed significantly greater increases in muscle mass and strength compared to the control group. The effect was significant enough that the researchers concluded it warranted serious attention as a natural anabolic agent. And spinach contains some of the highest concentrations of this compound found in any food. But beyond ectosterone, dark leafy greens deliver something that is critically underappreciated for leg muscle function: magnesium. Magnesium is required for every single ATP-dependent reaction in your body, and muscle contraction is fundamentally an ATP-dependent process. Without adequate magnesium, your muscles cannot relax properly after contracting, leading to cramps, spasms, tightness, and the kind of nighttime leg cramps that wake people up from sleep and leave their calves aching for days. Magnesium deficiency is extraordinarily common. Studies suggest that up to 70% of adults in Western countries consume less than the recommended daily amount, and leg cramps, weakness, and restless legs are among its earliest and most consistent symptoms. Dark leafy greens, spinach, kale, Swiss chard, collard greens also provide folate, vitamin K1, and a range of phytonutrients that reduce systemic inflammation, support mitochondrial function, and contribute to the overall nutrient density of your diet in ways that compound with every other food on this list. The whole is genuinely greater than the sum of its parts when these foods are combined consistently. We've covered 4 extraordinary foods so far, each one working through a distinct scientifically documented mechanism to preserve, rebuild, and strengthen your leg muscles. Now we come to the final 2, and I want you to pay particular attention to this next one because it addresses something that is almost universally overlooked in conversations about leg weakness. Yet the research connecting it to muscle function is some of the most compelling in the entire field of nutritional science. Food number 6, and this one is going to reframe everything you think you know about dairy. Full-fat yogurt, specifically fermented dairy with live cultures, not the low-fat, fruit-flavored, sugar-loaded version that lines most supermarket shelves. Real full-fat plain yogurt, ideally Greek style with live active bacterial cultures. And the reason this food belongs on this list goes far deeper than its well-known protein content. Yes, yogurt is an excellent source of high-quality protein, including a particularly valuable fraction called whey protein, which is rich in leucine, the single amino acid that most powerfully triggers mTOR activation and muscle protein synthesis. Studies have consistently shown that leucine acts as a metabolic signal in muscle tissue, essentially telling the cell nutrients are available, begin building. Greek yogurt delivers meaningful amounts of leucine in a form that is rapidly digested and absorbed, making it particularly effective when consumed either in the morning, when your muscles have been in a fasted catabolic state overnight, or in the evening, when slow-release casein protein from the same yogurt provides a sustained amino acid supply throughout the night, significantly reducing overnight muscle protein breakdown. But the truly remarkable aspect of fermented yogurt for leg muscle health has nothing to do with protein. It has to do with the gut-muscle axis, a communication pathway between your intestinal microbiome and your skeletal muscle that researchers have only begun to fully understand in the last decade, but which is already proving to be one of the most important relationships in human physiology. Here is what the science is showing us. The trillions of bacteria living in your gut do not simply sit there processing food. They actively produce compounds, short-chain fatty acids, neurotransmitter precursors, immune-modulating molecules that circulate through your bloodstream and exert profound effects on tissues throughout your body, including your muscles. In particular, a class of compounds called short-chain fatty acids, produced when beneficial gut bacteria ferment fiber, directly reduce systemic inflammation, improve insulin sensitivity in muscle tissue, and support the integrity of the intestinal barrier that prevents inflammatory endotoxins from leaking into the bloodstream and triggering the kind of chronic, low-grade inflammation we know drives muscle wasting. Research published in the journal Cell Host and Microbe demonstrated that germ-free mice, animals raised with no gut bacteria whatsoever, had significantly reduced muscle mass and impaired muscle function compared to mice with normal microbiomes. And when those germ-free mice were colonized with specific probiotic bacteria, their muscle mass and function improved substantially. This was a landmark finding because it established in rigorous experimental conditions that gut bacteria directly influence skeletal muscle mass and strength. In human studies, older adults with greater microbial diversity, meaning a richer, healthier gut microbiome, consistently show greater muscle mass, better physical performance, and lower rates of sarcopenia compared to those with depleted microbiomes. And one of the most powerful tools for cultivating microbial diversity is regular consumption of fermented food, with high-quality yogurt being among the most accessible, most studied, and most consistently beneficial. A cup of full-fat, plain Greek yogurt daily provides both the direct anabolic benefit, leucine-rich protein, and the indirect but equally powerful benefit of microbiome support for long-term muscle preservation. And if you add a tablespoon of ground flaxseed or a handful of berries, both rich in prebiotic fiber that feeds your beneficial bacteria, you amplify that gut muscle benefit significantly. Now, before we bring this all together, there's something that needs to be said, because knowing these 6 foods is only half the equation. The other half is understanding the enemies, the foods and habits that are silently and systematically destroying your leg muscles, even as you read this, and that will undermine every benefit of the 6 foods we've discussed if they remain unchecked. The first and most destructive is ultra-processed food, and not for the reasons most people assume. Yes, these foods are calorie-dense and nutritionally empty, but the specific mechanism by which they destroy leg muscle goes deeper than that. Ultra-processed foods are loaded with industrial seed oils, refined carbohydrates, and artificial additives that drive systemic inflammation through multiple pathways simultaneously, activating inflammatory transcription factors, disrupting the gut microbiome, impairing insulin signaling in muscle tissue, and generating oxidative stress inside muscle cells. Every time you consume a heavily processed meal, you are triggering a biochemical cascade that actively breaks down muscle protein and suppresses synthesis. The 6 foods we discussed today are fighting to build your legs up. Ultra-processed food is tearing them down. You cannot outrun that war with nutrition alone. You have to reduce the inflammation load. The second enemy is chronic protein undereating, which is far more common than most people realize, particularly among older adults who have gradually reduced their food intake as appetite naturally declines with age. The research is unambiguous. Adults over 50 require more dietary protein per kilogram of body weight than younger adults, not less, because aging muscles are less efficient at extracting and utilizing amino acids from food. A target of 1.2 to 1.6 grams of protein per kilogram of body weight per day is now supported by multiple major nutrition societies as the appropriate range for older adults seeking to preserve muscle mass. If you are eating significantly below that, no amount of high-quality food choices will fully compensate for the deficit. The third enemy, and this one will surprise you, is chronic sitting. Not because of the well-known cardiovascular effects, but because of something called anabolic resistance. When your leg muscles are not being stimulated through regular movement and weight-bearing activity, they become resistant to the anabolic signals from food and hormones. The same meal that would trigger robust muscle protein synthesis in someone who moves regularly produces a blunted, inadequate response in someone who is sedentary. Food and movement are not separate conversations for leg health. They are inseparable. The 6 foods on this list work exponentially better when combined with daily walking, resistance training, or even simple bodyweight exercises like chair squats and calf raises. The movement primes the muscle,